Okay, so it's 2:03 Eastern Time, so we'll get started. Thanks everyone for joining us today. My name is Johan Uruti. I'm the Director of Technologies for Spartacus, and I'm here with Heliel Morales, and we're going to discuss how to integrate IR thermography in day-to-day maintenance. This is scheduled for 1 hour. We'll keep 5 to 10 minutes question period at the end of this hour. So hopefully, in terms of sound and visual, everything's going to go fine. If there are some issues, please let us know. But if everyone's ready, let's get rolling. Eliel, you want to introduce yourself?
Yes, and good morning or good afternoon, depending on where you are. As Johan said, I'm Eliel Morales with FLIR. I'm in our business development team. I've been with FLIR since 2007 in various roles. I've been in the sales organization, in product management, in BD. Currently, my primary focus is on digital ecosystems, multi-sensor data, insights, condition monitoring, and focusing on key partnerships like where you're seeing here today between FLIR and Spartacus.
Excellent. And as for me, I'm the Director of Technologies and Operations for Spartacus. I've been there since the beginning of this project, the software. I'm a reliability engineer, and with Spartacus Technologies, we've brought a lot of experience in reliability engineering and services, meaning PM optimization, asset master data management, and asset health software. Currently, our software, Spartacus APM, is supporting more than 2,000 plant sites over North America and more than 3,000 active users on a daily basis.
So if you're not familiar with FLIR, our name stands for Forward-Looking Infrared. So we're a global company present in almost 200 countries, 4,000 employees. We are part of the Teledyne organization as well. But many people know our brand and our company because of infrared, right? And rightfully so. But we also do a lot of other types of technologies. You see some examples here on the screen, whether it's radar, GPS, or any sort of navigation system, laser. We do chemical and biological weapon detection systems. We do high speed, high performance visible imaging. So a lot of different technologies, a lot of different products. But today we're going to be talking mainly about infrared, right? And how to integrate infrared into your day-to-day job. So if you go back to how FLIR was formed and when we started bringing infrared cameras basically to our customers many years ago. This was in the 60s, and you can see how big these systems were, right? They were heavy, they were big, they were pretty expensive. And as we move through the years, you can see how technology allowed us to reach smaller, more compact form factors, lower price points. We now have cameras that can plug in right into your mobile device. We have infrared cameras built into a multimeter or a clamp meter. So you can see now how the technology has become more and more accessible. So again, this is how we've innovated since the company was formed in the 60s, and there's much more to come.
Excellent. So the agenda for today is really revolves around 3 questions: the why you should be interested in thermography, the what you're going to be monitoring, and the how to integrate these practices in your day-to-day maintenance. So let's talk about the why first. So we have a little poll to start with. What do you think of IR cameras? If you know about that, we're going to have a poll showing up on the screen as we speak, and we have a couple of possible answers. We're going to have you answer them and submit your answer, and we're going to be able to share the result and see the result on screen. All right, so for now, we're looking at 33%, or okay, a good 2/3% say it's the best tool in the world. A few people don't know what that is. A few people consider that it's another gizmo, and some of you may have seen that in the Predator movie with Arnold Schwarzenegger. That was pretty awesome, wasn't it? So, all right. So that was kind of a fun introduction. Yes. So an IR camera is a tool, and it could be considered just another tool, right? If we know how to use it at the right time, the right way for the right purpose, it will serve you and it will deliver great value. But of course, we need to discuss these couple of important items. So before we dive into thermography, IR, and temperature detection, I want to talk about symptoms, right? So when you're sick, when you have a disease, whether it's a flu, a cold, COVID-19, whatever, well, you go to the doctor or you analyze your symptoms. And basically, when it came to COVID-19, I liked this table here that was giving us the differences between cold, flu, and COVID-19. And the common symptoms between the three kind of viruses are very similar. You know, you have a sore throat, runny nose, or stuffy nose, or you have a cough, right? It's very, very similar. So, and the question I was asking myself was, every time I have a runny nose, should I take a COVID test, right? So you need to go beyond that. You need to go beyond these symptoms and focus on what's specific symptoms. And this is what we're going to discuss during that webinar, specific symptoms. So when it comes to machines, we're going to talk about failure modes, right? And again, I want to run another little poll with you guys. What are the failure modes of an electric motor? And so we're going to open up that window. The team here, Erwan, if you can open this up. What are the failure modes of an electric motor? I will let you type down what you think. Think about symptoms, right? What are the symptoms that an electric motor is failing? And I'm going to start populating that with what I believe is, yeah. And we're going to have a cloud of words showing up. So I will let you populate that, and we're going to see what are the top failure modes, top symptoms for electric motors. Okay, I can see some very good answers so far. All right, so overheating seems to be the biggest one in the center. Hopefully you can see the same thing as me on your screen. I can see vibrations. I can see bearing defects, high vibration, acceleration amplitudes. I can see lubrication issues. I can see power draw, amperage, loose bolts, winding arcs, elevated gas. So we got a lot of answers. Very good. Thank you very much for sharing that, guys. So we're not going to go through all of them one by one, of course. What we're going to do is I'm going to show you a very short list of failure modes or symptoms we typically identify for electric motors. So noisy, overheat, vibration, dirty, lack of lubricant, insulation issues. Okay, so you start with these failure modes, and then you ask yourselves, okay, what do we do? So should we address all these failure modes? And the answer is, well, it depends. Okay, it depends on multiple aspects. So let's talk about them. First, what we can assess at the failure mode level is the severity of failure if not covered, right? So if you don't cover overheat on a AC motor, what could happen down the line? So this AC motor is installed on this piece of equipment, and if this piece of equipment is down, well, the whole production line is down, which could be considered catastrophic, right? So there's really a very distinct relationship with criticality ranking. Now, the other aspect we can look at that is through probability of occurrence of these failure modes. So you're gonna look at the history of issues, and you're going to ask your maintenance people, okay, what's the probability of having overheat, noise, vibration, etc. Right? As you can see here, I decided to put high level of severity in terms of for all failure modes. And I decided to put different answers here in terms of probability of occurrence, which will in the end give me acceptable to intolerable risk associated with each of these failure modes. Right? And of course, we're going to address those failure modes based on the risk, right? What are we going to do with overheat? Since we consider it unacceptable, what are we going to do? So we're going to try to answer that question throughout this webinar, of course, but really very important to put back in place or in context overheat among all of the other failure modes. Very important. Another thing that is very important is to consider this failure mode, overheat, with regards to is it sudden or is it gradual? So you've probably already seen this graph before. If you have a sudden failure, it can be either through a constant mean time between failure. In that case, you will replace before it fails. If the MTBF is not constant, you will run it to failure. Or if you have a gradual decay, then you will monitor and at optimal intervals. And overheat is part of this last one here, right? For rotative asset and process equipment, especially. I'm not talking about electrical component, but really about rotative asset. The heat will have to be monitored at optimal intervals. We'll get there in a few minutes. Another thing that is very important to consider as well is that yes, it will be gradual. There will be a gradual decay for rotative asset, but typically when we look at the PF curve for a rotative asset, a bearing, for example, well, overheat seems to arrive pretty close to the reactive domain, which means that there's a very short interval of time where we can act and take action before we arrive at a catastrophic failure. Okay, we still have some time, but we'll have to monitor very closely to make sure we have enough time to plan and schedule for corrective action. So Eliel, how do we measure heat efficiently?
So let's talk a little bit about the, some of the science, some examples about infrared imaging. So the first thing is, just click. So we're all pretty familiar, I assume, with the laser gun, right? The spot thermometer, spot pyrometer, infrared thermometer, where you can very easily, very quickly take a temperature measurement, right, surface temperature measurement, and try to come up with an assessment of the situation. These products, there's certain applications where they do a decent job. They're obviously fairly low priced, but if you start getting into higher temperatures or some specific features, you can get into over $1,000, $1,500 for a single spot thermometer. So when you're scanning a target, right? So let's look at these electrical fuses. When you have a single spot and you have the laser pointer, you're basically scanning, right? Trying to find that spot that's overheating. So there's a lot of guesswork associated with trying to find that max temperature within the target that you're scanning. When you bring in a camera, an infrared camera, right into the mix, now you get to see the whole picture. So you're not only scanning the hottest spot jumps right in front of you. You can see it in relationship to the rest of the scene, right? Not only that, you can draw boxes, you can have areas of interest, circles, you can add additional spots, right? There's a lot of data you can add to the thermal image, and then obviously download and do additional reporting, get into Spartacus, share via email. So all this documentation, it's not just being able to quickly find the problem, but also having that picture that's worth 1,000 words, right? So that's a key advantage with infrared cameras. And they work in kind of this similar way. So you do have a detector that's capturing infrared energy, right? So it hits the detector element, and then what you have is a very complex calculations happening inside the camera. Then we come up with temperature values, right? That are associated with each of those pixels. So you may have a camera that's 100 by 160 by 120. You can have a camera that's 640 by 480. So we come up with this matrix of temperatures, right, based on the very complex calculations. Then we colorize, right, those temperature values, and that's how we get to a beautiful infrared image that tells the story, right, and tells us where to go and look deeper, and where to potentially see if there is a problem, and how quickly we need to act. When it comes to electrical, so Johan talked, on the mechanical side, right, the motor, but when you look at electrical connections, what's happening is, so anything that's loose, dirty, corroded, you're gonna start impeding the flow of current, right? So resistance goes up, and that leads to heat production, and that's how you're able to see this, with an infrared camera. We're looking at it with the naked eye, really, it looks okay. It doesn't look like you have a problem. But the moment you scan it with an infrared camera, you can clearly see the rise in temperature. As you can imagine, right, and this is how a lot of our technology started in infrared, was looking at substations, power lines. So there's a lot of electrical applications. I just listed some of them here and provided some additional images for you, but just look at all the different areas in a facility, right, that you can potentially look at electrical faults, things in the electrical side that could lead to catastrophic failure, that could lead to some sort of bigger problem, plant shutdown, right? Why is it important to look at the electrical components and do electrical inspections? Well, NFPA 70B, which is a standard for electrical and inspections, right? So it was just updated last year. They cover the procedures, how you should do the inspections, who should be conducting those inspections, and how we document those findings. So that has been there. What's changed just recently is that infrared imaging was recommended, right, in previous guidelines, and now it's required. It's a requirement to do regular infrared inspection of assets. So I just wanted to put this out there. If you want to read more about NFPA 70B, and if you're joining us from Canada, the equivalent in Canada, please go ahead. There's a lot of great information and a lot of, again, changes with the update to NFPA 70B. It's not just electrical, right? So there's a lot of other types of applications for infrared. You can see some great examples here: steam traps and bearings and conveyor belts and valves and boilers. So a lot of different areas where an infrared imaging product can help us find a potential issue. Then you're getting to another fascinating area, which is building inspections, building diagnostics. It's very important, right, on the energy side, making sure you don't have energy leaks, that that we don't have any sort of moisture problem that could lead to mold, and could impact the health of the people, the occupants of the facilities. So again, many different applications within building diagnostics as well. And then here you can see just many other things where infrared imaging is used. So finding pets and finding any kind of problem in agriculture, verifying product, or doing security or perimeter security. Just a lot of different applications where an infrared camera can come in very handy. And with that, I just wanted to kind of get a sense via a poll here that we're going to put on the screen. Do you already use infrared cameras in your facility, whether it's day to day or, not so regularly, or once a month, once a week? But, just wanted to get a sense of yeah, if you're using it, looks like we have a lot of people using it. Okay, so great responses are coming in. So electrical, a lot of people saying electrical. We do have a percentage of people that have not used the infrared. So we obviously want to get you introduced to the world of IR, and hopefully, be able to see how it can help you. But yeah, thank you for taking part in the survey. Just really interesting to see how the different applications, and again, some of you that have not integrated IR or are not using IR yet.
So can share a story, Eliel. A few years ago, I was doing construction at my house, and you know how winters tend to be pretty cold in Canada, and in my basement there was a plugged water line due to well, cold temperatures, and I used an IR camera to isolate the cold spot. Could see the line, to a certain temperature, and then the drop of temperature would tell me this is where it got stuck with the ice. So I used I don't know, how do you call it? A hair, some, what you use to make your hair. I don't
Oh,
remember
a
the name in
dryer,
English.
and
Hair dryer. Yeah, sorry,
Yeah,
thanks a
yeah.
lot. Sorry about that. I used a hair dryer to fix that. So anyway, so yeah, it can be used for a variety of problems, a variety of issues. There are lots of companies now who um, also have an expertise on building insulation, making sure that your energy consumption is efficient. They come in with a little camera and they inspect your windows and walls and doors and stuff to identify the air leaks, so where the heat can escape from your house. So if you already have a camera at your workspace, uh, I would highly encourage you to maybe uh, just get it for a few days and do a little survey at your house and find some air leaks and heat leaks at your house. Pretty handy. So the big question now is, how do we integrate IR thermography in day-to-day maintenance? That was the title of this webinar. So how? There's a lot of things to do. So we'll go back to our maintenance strategy. Get back to where we started. So earlier when we started this presentation, I said it's very important to focus on failure modes, right? So what are the symptoms of our machines? And out of these symptoms, what are the ones that we're gonna focus our efforts on? The ones where there is the most risk, whether it's unacceptable, it's unbearable, or it's something that we can live with, right? And it really get to your risk tolerance, right? There are some organizations where they want to cover all the failure modes whatsoever, because they're operating in an environment where it should be risk-free, right? And it can be because of regulations, it can be for so many reasons, safety, you name it, right? But in the end, we have to go back to that risk analysis that we showed earlier. And after we've assessed the risk, we're going to define the best maintenance strategy to deploy these activities. So it can be PM activities, preventive maintenance activities on the calendar based. It can be lubrication activities. It can be predictive with vibration, oil, IR. It can be ultrasonics. It can be through operator-driven reliability, right? It can be operators who take care of that. It can be through condition-based monitoring, right? Daily inspections, weekly inspections, taking measurements. It can also be run to fail. We can also decide that for some piece of equipment, well, even though it's overheating or else, well, the risk is not worth the effort we're going to put in, all right? Again, if we go back to that statement I made at the beginning of the presentation, is to do the right task at the right time, the right way, okay? So when it comes to overheat on a piece of equipment, I have a rotative equipment here. We said that the severity of failure, if not covered, is high because this is a highly critical piece of equipment. If it fails, it's going to put us down for a couple of hours, and this is unacceptable in terms of production, and it relates to our criticality ranking. We've talked about that. The probability of occurrence is medium. Now, what do you define as medium or high? Of course, there needs to be a very objective statement assigned to high and medium levels, of course, right? I didn't include that in here. If you're interested, I can give you some examples of what is a high severity, what is a medium severity, and same thing for occurrence. Here we said it's a medium, so in the end, we end up with an unacceptable risk. So that means this is something we need to cover. And now the question is how, right? So what we'll do is we'll measure the motor temperature with an infrared camera. Remember, we're just focusing on the motor here. Leave alone the gearbox and the other assets, right? It's just a motor. Measure the temperature with an infrared camera. What is the frequency? We're going to do it weekly, on a weekly basis, because as we've seen with the PF curve, there's a very short interval of time between when we detect a rise in temperature and really when it fails, right? So we'll do it weekly, and we'll take a measurement. We'll write down the maximum temperature, and we'll specify that it should never exceed 165 degrees Fahrenheit, right? So again, this is an example. This is an example of what I typically see of temperature measurement for rotative assets in the businesses I work with, or we work with, Spartacus and FLIR. And of course, there are different options, right? There are some permanent sensors for temperature, permanent cameras, right? And with triggers, but it ends up with your risk penalty number and the probability of occurrence. Here we said it's medium. So we figured going there weekly with a camera, take a temperature measurement would be sufficient to mitigate that risk. Now we're not done with that. Okay, we've defined the task, the frequency, and the measurement to take. Now we have to decide who's going to do that. Now it's going to depend on the organization you work with. Some organizations will have operators heavily involved in the basic care of assets, right? So they will be trained on how to use a camera. They will do a round every day or every shift even. I've seen places, especially some paper mills, where the operators grab a camera and do a quick round throughout the mill every shift, right? So pretty interesting. They're here, and of course they have tasks to do, but they are in the end operating the machine. Millwrights are typically a good choice for handling these type of tasks. They typically do condition-based monitoring routes. They do a bunch of tasks. So why not giving them a camera and having them, collecting these temperature measurement. Loop technicians as well could be. They also could be used as the temperature collecting people. So really, it depends on who's the best person to do it in your facility. It's about that, right? So I don't have a preference there. The right way now. What tool should we use? So, of course, my good friend Heliel could tell you all about the good stuff, the good cameras from FLIR. Here we can stick to, do we want a very advanced camera with a high resolution, a camera that will enable us to catch defects at long distance, or we can go with what we put on quote unquote entry level camera, like the one we see on the right, which is a FLIR One Edge model. It's connecting via Bluetooth to an iPad, for example, and also it embeds within the Spartacus APM app, which will enable you to easily collect pictures, IR pictures, collect temperatures, and trend them in your software or APM software, right? So really, again, it's about the level of detail you want to go to, the level of effort and investment you want to make. What are the considerations? So very important, in my opinion, is to think about where will this IR program reside. There are a couple of options. So it can reside in a CMMS. So we have built our IR or temperature measurement rounds in a work order that is pulled out every week, month, whatever, in our CMMS. What is the the advantage is that it's managed with the rest of the maintenance activities. Great. The downside, in my opinion, is that typically most CMMSs, they don't provide temperature trading, temperature trending capabilities, image storage, etc. So they can be limited when it comes really about the stuff that interests the reliability engineers. APM softwares can do the work very well. Spartacus actually does that very well. Camera software also will provide you with tools. FLIR has a great software that enables you to build your rounds and execute your rounds, build your reports as well. So multiple options, again, depending on how you set up at your organization and where you want the data to reside. Another consideration is about the trends. Now, what's very important, especially when it comes to process and rotative assets, as we've seen, the nature of the defects are gradual decay. So, of course, we want to be able to measure the temperature trend. So, again, does your CMMS allow that? Does it enable you to trend temperature? I've seen a couple of them do it, a handful of them do it, but I've seen most of them not doing that, and people having to write down temperatures on pen and paper, then transcribing on an Excel file those temperature values. APM softwares typically do that. I just inserted a screenshot of what Spartacus does with regards to temperature monitoring. And of course, your camera software will provide you with all the trends and tools necessary. Another consideration is about what happens after. So we've identified that there might be a defect on a piece of equipment, whether it's a breaker, whether it's a bearing or a reservoir, right? What do we do? And that's actually a pretty important question. What do I do? Do I go in manually in my CMMS and create a work order, which for some CMMS is done very easily and efficiently, or again, as with my experience with CMMSs, can be a hassle, or is it something that can be integrated with the APM software? Some APM softwares offer that connectivity with SAPs, Maximos, and other CMMSs of this world. Right? Another very key element to consider here. And the last key element to consider is training and implementation. I put that in red because in the end, it's not just about acquiring a camera and putting the camera into the hands of an operator or a technician. It's really about getting the value out of it, right? So again, for a very, very easy to use camera like the FLIR One Edge I have in my hand right now, Bluetooth connected to an iPad or a phone, there's really not much training needed, right? However, for more advanced cameras, there's definitely things to know. When we talk about the emissivity of objects, there's it can be quite complex, right? So training is very important, and implementation. How are you going to roll this out? Are you going to have everyone on board? Your communication through this project and the culture change. Right? When every time we talk about reliability projects, it's probably one of the most difficult aspect is management of change. How are we going to implement that and have people on board with these new ways of doing things? Right? So yeah, I really wanted to share these considerations. We've deployed so many programs like that throughout the years, and this is what we've seen as very important to share. So we're gonna finish that presentation with some case studies, of course, some successes we've seen around throughout the years. I'll start with this one. It's a program that I've deployed at a steel factory here in Quebec a few years ago. So I was actually in charge of deploying the full maintenance strategy program on laminating assets. And the least I could say is that there was a lot of issues, and especially one very recurring issue was that we had a lot of contamination through the lubrication pipes, right? So these big gearboxes were equipped with forced lubrication systems. And as you can see here, we can see the pipes here, and there's a blockage here. And we were unable to identify which pipes were blocked and where before we acquired a camera. So within a week, we were able to find a couple of them, and I have a lot of quick wins, right? So here you can see the before and after. We identified the problem, reopened the valve, played a little bit with it, and boom, the oil was flowing again. And also we identified overheating motors of loop systems. So in just, I think, over the course of 2 weeks, we identified 5 major problems. So I give you here the minimum to maximum savings that we made. It's a steel factory, so of course the amounts are pretty insane here. I guess average we probably saved $500,000 in just a couple of weeks, right? And we deployed a very basic IR camera, and yeah, it was done quite instantly. So low-hanging fruits with for us to catch at that steel mill. Another case I can show you is this is a tank. I think it's in the mine, if I remember correctly, and we avoided a $1 million shutdown here because we were able to find erosion here in the cyclone's slurry, right? So again, this to be repaired. It's not just a patch. It's pretty intense what we would have had to do. So we were very lucky to find that problem with an IR camera.
I'll walk us through a few more examples here briefly. So one of them was a steel mill here in the U.S. Where we were able to really save them a lot of money by being able to find these problems, and instead of having to shut down production for half an hour, we're able to do that in 5 minutes. So we saved them quite a bit of money with implementing infrared inspections. This one was at a hospital and doing steam trap inspection. So this particular hospital, imagine, has 800 of these steam traps. So if only 15% of them fail per year, and they go undetected because they're usually not monitored, they can cost anywhere between 100,000 and 300,000. annually. So this is, again, steam traps are quite popular at healthcare facilities. So, hundreds of thousands of dollars here that infrared technology is able to save them. We also did a study with CNA, the insurance company. The study itself is available online, but I just wanted to give you some of the highlights. Out of 6,000 IR surveys, we found 47,000 faults, right? And then, you can do some math here and, how many faults per survey. And, we arrived at, roughly $55 million worth of savings in this 5-year study. Basically, $8,500 per survey. So that's quite significant. The other piece here with the ROI calculation is that when it comes to energy efficiency and basically not fixing problems or leading to more energy consumption, that can be very easily calculated, right? So we know what's happening. We know the kilowatt per hour cost, and then we can just do basic math and arrive at some sort of savings or some calculation around, fixing the problem saves us this much, and that more than pays for the investment in the infrared cameras, the technology you need, and the software like Spartacus APM. So again, just some examples. This one more general in terms of just being able to do your own calculations and come up with an ROI for the investment. So key takeaways, Johan.
Yeah, key takeaways. So we're approaching the end of this webinar. If I have to summarize all of the key takeaways, so an IR camera, as we've seen, is an essential tool if it's used as part of a failure modes-based maintenance strategy. The idea is not to acquire a tool because it's a cool tool, because it's trendy, because it's a buzz, or everything. It's because it's going to serve a purpose and it's going to deliver value to you. So it's not just about acquiring a camera, it's about putting that camera as part of a global maintenance strategy, as we've seen. Thermography can be used to identify multiple types of failures. We've seen electrical, rotative, process, and so much else. Thermography can be easily implemented in maintenance programs to complement day-to-day activities. As we've seen, the purpose is to assign the right task at the right person to do it the right time and the right way, right? So part of the global maintenance strategy, we've seen the considerations. Where is your program going to reside? CMMS, APM, or camera software? How are you going to trend the data? How are you going to take action when you find defects? How are you going to create work orders? And especially, how are you going to train people and make that live long enough in your maintenance strategy program? And thermography provides a quick ROI. When used the right way, as we've seen, sometimes it's just low-hanging fruits with IR cameras. So thank you very much for your time today, for your participation in the polls. Heliel and myself we're very happy to spend some time with you today. And well, we have a few minutes ahead of us, and we're open for questions, comments, concerns that you may have.
Yeah, I'd like to just say the same thing. Thank you for taking time out of your busy day to come join us and learn a little bit about infrared, how to integrate it, the different ways in which it can save you and your organization a lot of money. So it looks like Anders, is the microphone open, or you want to type your question?
Oh, hi, Heliel. No, it was just a mistake. Thanks for a great presentation. Thank you.
Thank you, Anders. Okay.
Our contact information is here on the screen. If you want to reach out to us, if you want to learn more about Spartacus IPM or the FLIR offering, we kindly invite you to, go on our respective websites.
Yeah.
Thank you, guys.
Thank you for your time.
All right. Thanks, everyone. If there is no question, well, we're going to stop that webinar. Have a good day. Have a good rest of your week.
Good presentation. Thank you.
Thank you.
Thank you,
Thank you.
guys. Bye-bye.
Thank you. Take care. Bye-bye.